Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Here is Vitamath 35, and in this video I'm going to present the derivation of the Heron's formula for area of a triangle. So I already derived the area of a triangle in terms of the radius of the inscribed circle, which is area of triangle equals radius of inscribed circle times S, where S is half the perimeter of the triangle A plus B plus C all over 2. Then we define the angle bisector of a triangle as one that passes through the in-center, which is the center of the inscribed circle as shown in this figure here. So this is the angle bisector of this vertex angle A. So we have A over 2 and A over 2 here. Same is true at B and at C. All these angle bisectors pass through the in-center, or the center of this inscribed circle. So that these are b over 2, a over 2, a over 2, b over 2, b over 2, c over 2, c over 2. And that's called the distance from corner A, vertex A, to this foot of the radius perpendicular to side B as x. So that this is b minus x, and that is also x. So this is b minus x, this is c minus x, that's b minus x. So the remaining side here is c minus x, c minus x. So that from the figure, A is b minus x plus c minus x. And area of triangle is r times s. From the previous Vitamath problem, I also derived this formula. So also, A is b minus x plus c minus x, or A is b plus c minus 2x, or 2x equals b plus c minus a, or 2x equals a plus b plus c minus 2a. So by adding a, we also subtract a, so that's why this becomes negative 2a. Or 2x equals 2s, because a plus b plus c is 2s minus 2a. Dividing everything by 2, or canceling out 2, so x is s minus a. Because x is s minus a, we defined from this right triangle, because the foot of the inscribed radius of the inscribed circle is perpendicular to the sides, then we form this right triangle here, right triangle. So tangent of a over 2 is r over x, and x is s minus a. Following this pattern, we also say from formulas from trigonometry, this half angle here, tangent of b over 2 is r over s minus b, and tangent of angle c over 2 is radius of inscribed circle over s minus c. And tangent of a over 2 from trigonometry, although we can define this here because it is expected that the audience here underwent already trigonometry. So I hope that you can recall tangent of a over 2 is square root of 1 minus cosine angle A over 1 plus cosine angle A. Or if we square both sides, tangent square of a over 2 is 1 minus cosine of a over 1 plus cosine of a. Or tangent of a over 2 is sine of a over 2 over cosine of a over 2, where sine of a over 2 is square root of 1 minus cosine of a all over 2, and cosine of angle a over 2 is square root of 1 plus cosine a all over 2. Sine of angle a over 2 is square root of 1 minus cosine of a all over 2. So that's why tangent of angle a over 2 is square root of quantity 1 minus cosine of a over 1 plus cosine of a. So squaring, this would be the result. And from cosine law, a square equals b square plus c square minus 2bc cosine of angle A. So b square plus 2bc cosine angle A is b square plus c square minus a square. So therefore cosine of angle A is b square plus c square minus a square all over 2bc. So replacing this from this equation here, and take note that tangent of a over 2 is r over s minus a, so tangent square of a over 2 is r square over quantity s minus a square. So replacing cosine of a by this value expression, so r square over s minus a square, which is tangent square of a over 2 from here, is 1 minus, this is cosine of a, b square plus c square minus a square over 2bc, all over 1 plus cosine of angle A, which is b square plus c square minus a square over 2bc. Then simplifying, cross-multiplying, then take note that 2bc can be cancelled. So we have 2bc minus b square minus c square in the right side plus a square all over 2bc plus b square plus c square minus a square. So take note that 2bc is cancelled because the numerator has 2bc in the denominator as well as the denominator has 2bc on its denominator. So we just cancel that. Then we write this as r square over s minus a square equals a square minus quantity b square minus 2bc plus c square. So a square minus quantity b square minus 2bc plus c square all over b square plus 2bc plus c square minus a square. And we have to write r square over s minus a square equals a square minus quantity b minus c quantity square all over b plus c quantity square minus a square. So we have here difference of two squares which can be factored as into, so the numerator is factored into a minus quantity b minus c, and the other factor is a plus quantity b minus c. So equals a minus quantity b minus c times a plus quantity b minus c all over b plus c minus a times quantity b plus c plus a. So that's the way of factoring difference of two squares. So expanding inside, and we just rearrange this into a plus b plus c, and this one we write this as a plus b plus c minus 2a. So we have a r square over s minus a quantity square equals a minus b plus c, then a plus b minus c all over b plus c minus a, then a plus b plus c. We write this as a plus b plus c minus 2b. This one is a plus b plus c minus 2c. Then this one is a plus b plus c minus 2a. Then this one is just a plus b plus c. So take note that a plus b plus c is 2s. So we replace a plus b plus c by 2s. So we have r square over s minus a quantity square equals quantity 2s minus 2b quantity 2s minus 2c over 2s minus 2a times 2s. So all the coefficients 2 are cancelled. Then we have r square over s minus a square equals s minus b s minus c over s minus a s. So r square over s minus a square equals quantity s minus b s minus c over s minus a s. So we cancel s minus a here. Then we cross multiply, extract the square root. Then finally we have r, expression for r, which is equal to square root of s minus a times s minus b times s minus c all over s. So that's the expression for r. If we multiply s, the area of triangle, which is r times s, then we have area of triangle equals, we copy this, times s. Then putting s into the radical, it becomes square root of s square. Since we have s here, we can cancel s in the denominator, leaving s only in the radical. And of course, these three factors. Finally, area of triangle is square root of s times s minus a times s minus b times s minus c. And this is the Heron's formula. So that's it. That's the Heron's formula, and that's the area of a triangle given all the three sides, which is square root of s quantity s minus a times s minus b times s minus c, where s is half the perimeter, quantity a plus b plus c all over 2.